The most luminous galaxy ever discovered is cannibalizing not one, not two, but at least three of its smaller neighbors. The findings, reported in the journal Science and in the Astrophysical Journal, show that the galaxy's unusual brightness is being caused by material being gravitationally ripped off other galaxies. The cannibalistic galaxy, identified as WISE J224607.55 minus 052634.9, was discovered in 2015 by NASA's Space-Based Wide-Field Infrared Survey Explorer telescope, WISE. The galaxy is by no means the largest or most massive galaxy ever detected, but it radiates at some 350 trillion times the luminosity of the Sun. The new observations using the European Southern Observatory's ALMA, the Atacama Large Millimeter Submillimeter Array Telescope in Chile, have revealed distinct trails of dust being pulled into this monster galaxy from three smaller satellite galaxies. These trails contain about as much material as the smaller galaxies themselves, and it's unclear whether those galaxies will escape their current fate or whether they'll end up being completely consumed by their luminous neighbour. Most of this galaxy's record-breaking luminosity comes not only from the stars in the galaxy, but also a collection of hot gas and dust concentrated around the galactic centre. And at the heart of this cloud is a truly monstrous supermassive black hole, at least 4 billion times more massive than the Sun. This massive black hole's intense gravitational pull draws in matter at high speed, crashing together and heating up to billions of degrees, causing the material to shine with incredible brilliance. Galaxies that contain these type of luminous black hole-fueled structures are known as quasars. And just like any engine on Earth, this galaxy's enormous energy output requires an equally high fuel input. In this case, it means the gas and dust needed to form stars and planets to replenish the cloud around the central black hole. This new study shows that the amount of material being accreted by the galaxy from its neighbours is enough to replenish what's being consumed, thereby sustaining the galaxy's tremendous luminosity. The study's lead author, Tanio Diaz Santos from the University of Diego Portales in Santiago, Chile, says the feeding frenzy's already been ongoing for some time and is expected to continue for at least a few 100 million years more. This kind of galactic cannibalism is not uncommon. Astronomers have previously observed lots of galaxies merging with or accreting matter from their neighbouring galaxies. In fact, our very own galaxy, the Milky Way, is currently accreting material from two nearby satellite galaxies, the Large and Small Magellanic Clouds, and it's also consuming material from another galaxy on the other side of the Milky Way called the Sagittarius Dwarf. But this newly detected galactic cannibal is by far the most distant galaxy ever found to be accreting material from multiple sources. In fact, the light from its cosmic feast has taken some 12.4 billion years to reach us. So astronomers are seeing this object at a time when our universe was just 1/10 of its current 13.8 billion year age. That makes this galaxy fit into a special category of especially luminous quasars known as hot dust-obscured galaxies, or hot dogs. Astronomers think lots of quasars probably get some of their fuel from external sources. One possibility is that these objects may receive a slow trickle of material from the space between galaxies. Another is that they feed in bursts by eating up other galaxies, which appears to be what's happening with this hungry monster. Now, it's still unclear whether this beast is representative of other obscured quasars, those with their central black holes obscured by thick clouds of dust, or if this is a special case. One of the study's co-authors, WISE project scientist Peter Eisenhardt from NASA's Jet Propulsion Laboratory in Pasadena, California, says this galaxy may well be one of a kind. That's because it's nearly twice as luminous as any other galaxy found with WISE, and because it formed so very early in the universe's history. However, Eisenhardt and colleagues have found other, admittedly smaller but generally similar galaxies with WISE, distant, dusty, and thousands of times more luminous than typical galaxies today. So it could be that astronomers are seeing what's going on during a key stage in the evolution of galaxies and obscured quasars. Ultimately, this galaxy's gluttony may lead to its self-destruction. Scientists hypothesize that obscured quasars that gather too much material around them could end up spewing gas and dust back out through the galaxy. And this onslaught of material could halt the formation of new stars, essentially pushing the galaxy into early retirement while other galaxies continue to renew themselves with the birth of new stars. I'm Stuart Gary. You're listening to SpaceTime.
Time.
This month will provide skywatchers with their best view of the comet 46P Watanen. The small, short-period Jupiter family comet has an aphelion, that is, most distant point in its orbit around the Sun, of between 5 and 6 astronomical units, hence the name Jupiter family comet. An astronomical unit is about 150 million kilometres, or 8.3 light minutes, the average distance between the Earth and the Sun. Watanen has an orbital period of 5.44 years and is estimated to be about 1.2 kilometres wide. On December the 16th this year, the comet will pass just 11,680,000 kilometres, or 0.0781 astronomical units from Earth, reaching an estimated magnitude somewhere between 7.5 and maybe even as high as 3, making it the brightest close approach for the next 20 years. Needless to say, astronomers worldwide are organising an observing campaign to capitalise on the favourable circumstances of this apparition. Interestingly, this comet was the original target for the European Space Agency's Rosetta mission. However, that target was later changed to Comet 67P Cherenkov-Gerasimenko when mission managers failed to meet the launch window for Watanen. Still, the 2018 close approach combined with Watanen's brightness provides a great opportunity to study a potential future spacecraft mission to this target. To find out more, Andrew Dunkley is speaking with astronomer Dr. Fred Watson.
A comet called Watanen, and the reason we're talking about that is because it's almost upon us, not literally, but it will be visible in the night sky, we hope.
Yes, that's right. It will indeed be visible in the night sky. It's the person who discovered it, despite having a Norwegian or Scandinavian sounding name, was actually American, so it's probably Watanen.
Okay.
With a W, who was at the Lick Observatory when he discovered this comet back in 1948. It's what we call a short period comet. From time to time, it passes close to Jupiter, which kind of disturbs the orbit. So its orbital period changes slightly. It's very interesting the way these things evolve because of the gravity of the giant planet Jupiter. But this year, we've got a really good chance of seeing it in the night sky as it progresses southwards. It's closest to the Earth on, I think, December the 15th and 16th, when it will attain what we call third magnitude, which means well within the naked eye visibility. The only problem is it will be rather a full moon at that time, and the comet itself has got a very diffuse coma as the nebulous region around the comet caused by the ices on the comet outgassing and turning into a plasma. So it's diffuse. It means it's not, a well-defined, sharply defined object. It is going to be, I think, quite difficult, but with binoculars, it should be easy to see this sort of fuzzy patch. There will be plenty of places on the web to check exactly where it will appear in their skies. But it's looking good. There's some very nice images already of Watanen taken by people with normal small-sized telescopes.
And it's green, which is...
Yeah, the green is... I think that comes from carbon monoxide emission, if I remember rightly.
So it's a pretty dirty comet.
All comets are dirty.
Yeah.
That's what they are, balls of dirt held together by ice.
Okay, so that's one to keep an eye out for, and it'll be closest to Earth since 1950, and that'll happen on December 15 and 16. And I'm guessing because of our orbital properties and its movement, most people will be able to see it.
Yes, I think that's right. It's in the northern sky when it's at its closest, but it's sufficiently far south that we should see it in the south too.
That's Dr. Fred Watson, an astronomer with the Department of Science.